calculate the intensities X for both the 9 magnitude earthquake in Japan and 7 magnitude earthquake in New Zealand. So without knowing this logarithms, right, it looks like there's only a difference of 2 units. 7 and 9, 9 minus 7 is 2 units. Okay, let's see what the difference in intensity is. Okay, so using X equals to 0.001 times 10 to the power of R. When I want the 9 magnitude earthquake, so X, when R equals to 9, X will be equals to 0.001 times 10 to the power of 9. Are you able to do this without your calculator? Then what is the answer? 10 to the power of 6. All of you can see that? 10 to the power of 6? Because 0.001 is actually 10 to the power of? Negative 3. Okay, good. So this is 1 million. So this is for Japan. Then for New Zealand, when R equals to 7, X equals to 0.001 times 10 to the power of 7. And we get 10 to the power of 4. This is for New Zealand. So we do know that when the value on the Richter scale is 9, it is more devastating than that for Richter scale 7. We normally, layman, will think that, hey, there's a difference of 2 units only. But now you can see, in actual fact, what is the difference in the intensity? 100 times. Where did this 100 come from? 10 squared. Okay, 10 to the power of 2. That 2 over there refers to the difference in the magnitude. The difference in the value in the Richter scale. So that's why we have 100 times difference. Okay, so next time when you read the news, it says, if they ever compare the magnitudes of the earthquakes for Richter scale, please know that if they tell you, oh, there's a difference in 7 and 8, for example, doesn't mean that it's just a small difference. It means it is 10 times more powerful. Yes?
So what the number they want to choose like 1 digit? Why don't you choose 2 digit?
What do you mean 2 digit?
Like 70 then 90.
70 then 90?
I mean like 1 then you say 10 times more than 10 then 10 times 400.
Okay, because the values will get bigger and bigger. You see, would you like to say that the intensity of the earthquake is 1 million? Then the intensity of another earthquake is 10,000. Or would you prefer to have it as 9 and 7? 9 and 7 is smaller numbers, easier to work with. Okay, so if we continue to consider on the Richter scale, the value is 1. Then what does that mean? On the Richter scale, value is 1. Okay, let's investigate. So when R equals to 1, X will be equal to 0.001 times 10 to the power of 1, which is 1 over 100, right? So you see on the Richter scale, we have from 1 to 10. That is on the Richter scale. In reality, when we talk about the actual intensity, it ranges from 1 over 100 all the way until which power? 0.001 times 10 to the power of 10. That's the maximum. So that will be 10 to the power of 7. It will be 10 to the power of 7. From 10 to the power of negative 2 to 10 to the power of 7. This is a huge range in between. So it is more convenient to use logarithms, the Richter scale, to make those big numbers, those very small numbers, become numbers that we are more comfortable with handling. From 1 to 10, much easier. Okay? So this is an example of how we use the logarithms in real-world applications. We have a few more examples over here. Radioactive decay. You're familiar with this word, isotope? Yes. Chemistry, right? Okay. So there is a radioactive isotope called krypton-85. It will decay to half of its original amount in 10.72 years. This first sentence, do you understand it? Decay, so the mass will reduce and it will become half of its amount in 10.72 years. So assuming the initial mass, let's say the initial mass is 1 kilogram. After 10.72 years, what is the mass?
500 grams.
100 grams. After another 10.72 years, will it become 0?
0.25.
You see, in the first 10.72 years, how much did we lose? We lost half of it, so we lost 500 grams, right? In the next 10.72 years, should we expect to lose the same amount? No, we will lose another half of it. So 250 grams this time. In another 10 years, so that is the 10. Yeah, the third batch of 10 years, we will lose now 125 grams. Okay, that is called radioactive decay. This value is known as the half-life. Half-life. Heard of half-life? Huh? Half-life. Yeah, okay, but it's nothing to do with the game. This is just known as the half-life of this krypton 85. Okay, it is 10.72 years. So the amount left is given by the equation A equals to A naught. Look at this little zero over here. Okay, it's just a subscript, just a little zero to indicate something. I'll tell you what later on. The amount is given by A naught times e to the power of negative blah blah blah, where t is the time in years. And then they tell you that a sample has a mass of 43.9 grams after 2 years. Okay, so if I want you to substitute these values into the equation, where does this 43.9 go to? Is it A naught, or T? Okay, mass of 43.9, right? So it must be A. Where does this 2 go to? A naught, or T? T. So if I were to substitute these values in, how many unknowns are left?
1.
Which is? A naught. So what does A naught represent? Let's figure it out, okay? Find the, oh yeah, actually it's given here already. Find the initial mass of the sample. Since I haven't told you what A naught is, let us just put whatever we can inside first, then we investigate again. Okay, so for part 1.
So A naught is not log, right?
No, it's not a log. It's just A naught, N-A-U-G-H-T, not for nothing. Okay, so part 1, we have substitution. 43.9 equals to A naught, e to the power of negative 0.06466. What is the value of t? 2. Okay, can you help me find out the value of A naught? With your calculator, of course. Okay, so round off to give us 50.0. Am I right? Okay, now I'll substitute this back into the original equation. Because A naught is a constant. So, mass equals to 49.961 times e to the power of negative 0.06466 t. Now, do you agree that my equation is now changed to this? Because A naught is a constant, right? All okay so far? Have I lost anybody? Then, part 1 says find the initial mass of the sample. What does the word initial mean to you?
First.
At the start.
Yeah.
So at the start, what is the value of t? What will you expect the value of t to be at the start? 0. So go and highlight this word initial and put it over here. T equals to 0. Because we will use terms like this, and you are expected to be able to substitute in the correct value of t. So since t is equal to 0 at the start, then what is the initial mass? What do I have to do to my equation over here? Submit 0. So what do you think is the answer for initial mass? Initial mass equals to 49.961, which is approximately 50.0 grams.
So why you get it?
Mass be equals to something divided by something times 100%. Okay, I hope you remember this one. Percentage change lah. Times 100%. Okay, what goes in the numerator, what goes in the denominator? If I want the percentage that has decayed. Common sense.
Denominator is the start.
Initial minus. Okay, so percentage decay, will you say that it is amount decayed or amount lost? over original
I thought it's-
mass.
I thought original over
T equals to 10. But when I substitute T equals to 10 into my formula, I get the amount left. Right? See this formula over here gives me the amount left after T years. Get it? So how do I find the amount lost?
original minus amount
Okay,
left.
so original 49.961 minus, then I substitute in the value, right? 49.961 e to the power of negative 0.06466 times 10 divided by 49.961 times 100%. Not sure if I have told you how important this percentage symbol is. Have I told you before? If you leave it out, you'll be wrong. You must have the percentage symbol. You don't wait until the last step, then you just conveniently put in the percentage symbol. Because that will be mathematically wrong. Okay, so substituting all these values, we will find that the answer is actually, let me just check the answer at the back. Now left, 1/4 of A naught must be equal to A naught times e to the power of negative 0.06466 t. I choose to use A naught because I know I'll cancel off. I don't want to write down so many decimals. Right? This is from the equation for part 3. The original amount is now reduced to just 1/4 left. This is the final mass. So just cancel A naught and A naught. And I'm sure you are able to take ln on both sides to find the value of t. Alright? Somehow grew up with the misconception that percentage decay can be written like this. So I just times 100 without putting the percentage. Times 100 over here, then they conveniently put in the, then when they key to a calculator, right? Key, you get 47.6. Then they just put a percentage over here. Anything it is correct. But here comes Mr. Wong and I thought he's wrong. Reason? This over here is equal to 47.6. This over here is equals to 47.6 divided by 100, which is 0.476. Nobody in the world will tell you that 0.476 is the same as 47.6. Do you understand? Okay? So don't make this kind of mistake.
So,
Yes?
let's try a bit. How do you remove the T outside?
What do you mean the T outside?
Yeah, I made both long already, but then I got e power. I got 1 to the power of negative 0.06466 bracket T, but I don't get the T out.
Like that?
Yeah. I put non negative 4 negative power. Power negative 1.
Isn't it like this? Power law. We just bring the entire power down. Then ln is just 1.
Oh.
Wait. Oh, sorry, this is not negative 4. This is
4
ln 1 over 4. So use your calculator to find out this value. Now then just divide up. That's it. I substitute in the value. They will always give you this information. After 12 months, 40,000. Substitute in. That is how we start finding the value of k. So 40,000 equals to 50,000 e to the power of negative k times 12. So e to the power of negative 12k equals to 4 over 5. Negative 12k equals to ln 4 over 5. K equals to ln 4 over 5 divided by negative 12, which is given to be 0. What do you have? Okay, so I have this value for my k. After 20 months, yes?
But I thought if you put log on both sides, right?
Ah.
It would be 1 to the power of negative 12k.
1 to the power of negative 12k.
Yeah.
I put ln over here, I put ln over here. This negative 12k must go over here. So expected value after 20 months, V equals to 50,000 e to the power of negative k, which is 0.018595 times 20. So you get the answer. Part 3 you get a negative number, then it cannot, then something is wrong, you are working already. What? You mean for part 2 or part 3? Okay, let me do part 3 now. Given that the value first drops below 20,000 after n months, find the value of n. Value drops below 20,000. Do you agree with my first line? Do you see inequalities? There is an inequality question. Okay, so V is supposed to be equal to 50,000 e to the power of negative 0.018595 t. And this same V is supposed to be less than 20,000. Okay, so I can remove this part already. This is now my inequality. Next, I am trying to solve for t, right? But in this case, they tell you it is after n months. Okay, so my t has now become n. Because that's the amount of time. What would you like to do next? I want to solve for n. What is the most obvious thing that we should be doing? Divide by how much? 50,000. Divide by 50,000 on both sides. So we are dividing by a positive number, no need to flip. Negative 0.018595 n equals to 2 over 5. Less than. No need to flip the sign. What would you like to do next?
1 over
Take ln on both sides. There is no 1 over. You do 1 over doesn't help you at all. Okay? You take ln on both sides. So ln e negative 0.018595 n less than ln 0.4. 205 is simply 0.4. Alright? Next. We have negative 0.018595 n is less than ln 0.4. Okay so far?
Yes.
Now I still want to make n as the subject, right? What should I do next?
Divide negative number to the side.
Flip ln 0.4 divided by negative 0.018595. So n is supposed to be greater than 49.289. Okay, so since n must be greater than 49.289, n must therefore be
49.
hello, bigger than 49.2.